I shall discuss about field investigation. This is geotechnical engineering basically consisted of several parts. First, field investigation and preliminary data collection. Next, laboratory testing. And final stage is interpretation of test results. Today, I shall discuss about field investigation. Field investigation is the most important part of geotechnical engineering. It covers the local history, local geology, geomorphology, local geography, besides formation study. This boring. Why it is termed boring? Why shall not termed as holing, since we are going to make a hole? Because open the vanity bag, take out the money bag, close the vanity bag, open the money bag, close the money bag, open the vanity bag, put the money bag and close the vanity bag. So much of repetition of open and close. Surely one feels bored. So it is termed as boring, not holing. For formation study, boring, we require boring, drilling, sampling with other field tests like standard penetration test, dynamic cone penetration test, and static cone penetration. So many tests are there. Besides, there are some modern developed techniques also there. There are many methods of boring operation. Just for example, shale and agar method, simplify mud bore, which we normally term as mud boring, or rotary bore, agar bore. Out of all these methods, rotary boring with mud circulation is the best suited method for sampling and other field tests. Demerits of shales and agar mainly is many times shale stuck by cutting spoils. And agar, in agar there are two types of, one is with air vent, other is without any air vent. One must use the air vent agar. Agar boring is suitable for a very shallow depth in C5 soil, not in other soil. Simplified mud bore is feasible for a shallow depth of any formation other than cobbles and boulders up to a depth of 50 to 60 meters only. Besides this boring method, there are some observations are required, that return water color, loss of water, ratio between the pumped in and return water amount. All these has an important role. Besides, two types of soil never be same order. God has created, our art has created by natural process or by evolution or by anything, but it is nowhere two types of different soils appears the same color. This is a big of rotary boring. It is a boring was there. It is a hydraulic operated by hydraulic spindle, and one bead was attached at the bottom of the drill rod, so it can be drilled up to adequate depth. This capacity of this is 300 meter, but in fact I am not going to give you any misportion. So far I did up to 120 meter only. Field test, these are consisted of standard penetration test mainly. In our IS it is 2131. IS 2131, that is the Indian Standard Code has introduced. And this test was originally introduced by Dr. Carl Tajagi in 1927 for estimation of SBC of shallow foundation. Nowadays, this test has wide popularity throughout the globe. It gives relative compaction, that is relative density, presence of very thin seams besides texture of the formation. This is, you see, in this photograph, you can see that after drilling, the hole was cleaned with water by low pressure pumping water, pump in water. And here, after cleaning the hole, the SPT split spoon sampler has been driven by this drive weight. In this test, a split spoon sampler was hammered down using a drive weight of 63 to 65. Originally it was 65, that is 140 pound. Now in some country it is 65, 63, in some country it is 64, some country it is 65. It is now considered as 65 plus minus 2 kg. So we consider it is 63 to 65 kg through a free fall of 75 centimeter. The sampler length is 45 centimeter and numbers of blows required for each 15 centimeter penetration shall be recorded separately like this: 12, 20, 30, whatever it may be, and the N values considered second and third 15 centimeter penetration. That means this shall be treated as N value. This was neglected because there will be some looseness due to during the time of cleaning of hole, and there are some cutting spoils may be there. So this is neglected, and second and last 15 centimeter penetration value was recorded as N. This N will require some correction like overburden pressure correction and dilatancy correction under water table condition for silty sand. Very fine grained sand with silt, this dilatancy correction is there. The soil sample obtained from SPT may be used for classification analysis. In addition to this, visual and megascopical identification, determination of soil moisture, approximate compressive strength can be determined at site, which shall give purposeful information in final stage of compilation and computation work. In addition to this, N-value has direct relationship with, with the frictional angle phi that was also suggested in IS 6403, and as settlement also, foundation settlement also, that was also suggested in 8009 part 1, and lot of other things in empirical equations are there directly. It is unconfined compressive strength, elastic modulus. All these are, there are some correlationships which are, although it is empirical, but they are almost accurate. The soil resistance, stress absorbing capacity also be estimated from N-value using impact fault theory of falling body, considering base area of split spoon sampler as 10 cm square. Since OD is 5 cm and ID is 3.5 cm. This is, you see. The recovery shall be measured very correctly so that we have penetrated 45 cm, and if full length is recovering, that is, our formation is non-streaky. That means both inside and outside friction is less. Here, using this apparatus, it is carbide type rapid moisture meter. It is very handy. It can be carried very easily. We can take it to the site also. We can determine the soil in place moisture directly at site. You see, these samples, if it is taken in undisturbed condition also, during transportation, during sailing, and during storing, there may be some humid effect will be there. So we can estimate the soil moisture at site, which shall be useful and purposeful in final stage of computation. Another, in this picture you see, this is pocket penetrometer. We can measure the unconfined compressive strength of the soil. Of course, it is silty clay or clay soil only. During this test, we should take in this upper portion shall be neglected because it is considered that this soil shall be disturbed, and lower portion neglected because during driving there may be some amount of compaction at the lower portion. So in between this 5-6 reading, after taking 5-6 reading, we can take average. This is very small. It is normally field geotechnical engineers, they are carrying in their pocket itself. With this moisture meter, reagent we are using calcium carbide, which is known as carbide, and when calcium carbide react with water, it will produce acetylene gas and calcium hydroxide. So with that acetylene gas itself gives some deflection of this meter, and we can take it. And directly to derive the moisture content, we must use moisture reading divided by 100 minus moisture reading, and we should convert into percentage. This will give you in place field moisture. Dynamic cone penetration, there are two types of dynamic cone penetration. One is with mud circulation, Another is without much calculation. And static cone penetration tests are nowadays less preferred since the tests have some demerits like higher resistance reflected in very fine-grained siltation. Refusal values are obtained at a shallow depth, mainly due to soil slip around the rod. Some problems are noticed in case of hard clay formation also. Undoubtedly, these are purposeful for academic and research purposes, but it has very less importance in planning and design. Since finally we require few basic parameters like unit weight, cohesion, frictional angle, angular repose, and consolidation parameters. These are only. Another test is undisturbed soil sample collection, which was covered under IS 2132. If I am not doing any crime, I should say that the true undisturbed soil sampling not at all possible. During my last more than 5 decades in this field, I have been working honestly and sincerely using all developed and modern methodology from thin wall sampler to piston sampler, triple tube barrel, air compressed sampler, but nowhere I was getting 100% undisturbed samples. In some samples, we are penetrating 45 centimeter or 50 centimeter. Inside we are getting soil about 40 centimeter or little less. So this is not 100% undisturbed. Nowadays, as per IS has as per IS recommendation, thin wall tube sampler area ratio less than 10 of sufficient length is best option for collection of undisturbed sample. My opinion, 50 mm dia, 450 mm long thin stainless steel and seamless steel tubes are more efficient for reliable accuracy of about 80%. Larger the diameter, more the disturbance. Besides area ratio, there are a lot of other influences like both inside and outside wall friction during penetration of sampler, probable complexion of soil formation, particle rearrangement, particles breakdown, ooze out of soil water, connecting rod verticality at greater depth of course. These are the basic problems during collection. So, larger diameter, we do not require larger diameter, we require 50 mm diameter is sufficient. However, static penetration of sampler using hydraulic pressure is better than driving the sampler. Errors and disturbance is proportional to depth. In greater depth, even the gross recovery ratio is much less. More the depth, error shall be more. Number one, verticality of rod. Number two, during penetration, the weight of self weight of the rod itself gives little more energy, which shall disturb the formation below the sampler. So, 50 mm size is quite sufficient for collection of reasonable amount of error, disturbance, undisturbed sample can be collected. However, soon after withdrawal of the sampler, the gross recovery should be measured, visual identification at both ends shall be made, color, texture, plasticity, etc. preferably assessed before both ends sealing with molten paraffin. We have to seal both ends to retain the moisture intact. You see, here we are penetrating with this hydraulic drilling rig. We are penetrating the drill using hydraulic pressure. So sampler penetration under hydraulic pressure using valve 90 drill unit. After collecting out the sampler, we are sealing to undisturb the moisture content and other properties. And after that, what we require to do, to make a bead at the ground. And now it is too simpler. When another will be coming, then it should be filled. We should put a gunny bag here, that is jute bag, and keep some water above it with some soil mixed with water. We shall be putting there to retain the in situ properties. With this precaution and care, we can at least expect less disturbed, undisturbed soil samples for further laboratory testing. Now, we understand why should we adopt safety factor in final compilation and computation. There is no doubt, in my opinion, there should not be no doubt about taking safety factor in our final computation, because from initial stage to final stage there are some amount of errors there. So we are bound to adopt some safety factor in our final computation. Further, except academic and research purposes, no one should adopt simple method at all time. But one should take simple method for planning and design purposes. Another is open test pit. Open test pit gives much more information about soil formation. It is very essential for shallow furnace. One can physically verify the depth of formation besides collection of disturbed and undisturbed samples, estimation of shear strength, compressive strength, in situ soil moisture content, excavation feasibility, cut slope angle, etc., which are most valuable information in construction management. Let us consider feasibility of open excavation. If you see, it is about 4.5 meters excavated, almost vertical, not vertical, almost vertical. We are examining the difference of stratum here, which cannot be recorded with a small bore of 150 mm or 200 mm like that. But open trial pit, if we can make this open trial pit excavated, then it is feasible. We can directly say it is feasible for open excavation. Cut slope, this slope, it is almost vertical slope. So we can say the open vertical excavation is feasible. Normally, most of the people, what they prefer, 1 in 0.5 slope in clay soil and sandy soil, 1 in 2 slope is preferred and recommended. But if we can make some lesser angle, slope angle, then it is very good enough. We can save a lot of money and we can give best services to our client. Another important test is plate load test. In earlier days, plate load tests were conducted for estimation of soil pressure, that means SBC, and foundation settlement for designing purpose. But nowadays, plate load tests are being conducted for physical verification and confirmation of theoretical estimates. IS 1888 has suggested details about the plate load test. Normally, loads were conducted on different plate sizes varying from 300 to 1200 mm square or circular plates at the foundation depth. However, I suggest, based on my experience, to use 600 by 600 plate at a depth at any depth below the ground level if formation is same with that of foundation level and preferably above water level. Variation of load test results were noticed while conducted below water level. This is a view of load test. This is the general arrangement. These are the loading. And these are the hydraulic jack. This is the pump. We are applying pressure here in hydraulic pump. The pressure and area of the ramp. Pressure and area of the ramp. From there we are calculating the load, which load is going there. And finally we have recorded the deflection using sensitive dial gauge. Sensitive means it should not be more sensitive than 0.01 mm. If it is 0.001, then it will be very difficult to maintain the initial readings. So it should be 0.01 mm is sensitive is sufficient. And normally IS has suggested to use minimum 2 numbers of dial gauges. 3 is more than 2, 4 is more than 2. So one can use 3 and 4 both. But in any case, if we use more than 2, then it should be 4, not 3. Using 3 dial gauges, this created little problem in computation of mean settlement. That means if one side, if we are providing 3 dial gauges, this side is 2 and this side is 1. So it will give, arithmetically we can take the average, but that shall be not accurate. If we use 4, this corner, this side we give, it is also 75 by 75 mm plate. So this corner 1 dial gauge, this corner 1 dial gauge, this corner 1 dial gauge, this corner 1 dial gauge. So we can take this way 1 average, this way 1 mean, and finally taking together we can calculate the mean average settlement, mean settlement. So I suggested either using 2 or 4, never 3. In many cases, different dial readings are noticed in different gauge, and generally most of us prefer to adopt average which always may not be correct. CG of test plate. There is a steel plate. There is a steel plate below this loading arm. This is the loading arm. There is a steel plate is there, 600 by 600. CG of test plate and load. CG of this load application point and the test plate should be same axis. A slightest variation may double the reading. I had a bitter experience during my long 5 decades experience. In one load test, the load test was conducted in my presence, in presence of me, and that too after my full satisfaction only. During test operation, settlement in one corner comparatively much higher than other side. Of course, under any case, the settlement was within the permissible limit. For me, due apology to all, neither code is Bible nor bait for me. I decided to verify the actual fact. My doubt was true. After excavation, it was found that about 300 below the test plate, a local pocket of substratum was there, which required me to provide the foundation about 500 millimeter further below. You see, because of this doubt, it is not possible to conduct load test everywhere. So I have to verify one place, and without taking any risks, I am providing 500 mm further below the original design depth. In addition to this, our codal provision says that the pressure increment must be based on soil type. For C0 soil, this type of loading, and C5 soil and 50 soil. But I should prefer to say that if possible, each stage of loading shall be maintained minimum up to 24 hours. And the final loading, 2 times of estimated safe soil pressure or SBC, shall be maintained for minimum 72 to 96 hours, which shall give better indication of probable foundation settlement. A paper was published in National Conference of Institution of Engineers. Dynamic plate load test. It is very simple and quick test for estimation of SBC, foundation settlement, elastic modulus, Poisson ratio, etc. within a very short time. Initially, the equipment was developed for compaction quantum assessment, but nowadays impact force of falling object theory, this test became popular all over the world, more especially in mega projects. Many countries also prefer to conduct this test for shallow foundation in difficult terrain like in accessible hilly areas. After a detailed comparative study between conventional C5 method and dynamic plate load test, a very nominal difference was noticed, about 9 to 12%. The details are published in an international journal. These are the procedure for calculation. Finally, we can calculate the SBC and settlement also. We can calculate the settlement also, subplate reaction coefficient also. I do sincerely feel that this shall be useful for young professionals. Further, I want to add that each and every project site has different problems always. Neither any theory nor codal provision help to tackle these problems. One must ready to face all these challenges like our life journey. During 1982, I had required for back hammering for months together to recover my drilling tools VX2 NX, casing pipes, BW and W rods, costly core barrels and fittings, which are worth about few lakhs during that time, when these are stuck up at a depth of 80 meters below bed level. During that time, few lakhs is very big thing. About 2 to 3 months I had required to backhammer to withdraw my distance. In 1994 I lost 78 meter very costly drilling accessories while only 12 meter remaining to complete the drill hole, and as a result I had to incur loss of 1 month establishment cost. I have many bitter experiences in my life. Fortune and misfortune are twin brother and both are child of geotechnical engineering. Person and misperson. Both are there. In geotechnical engineering, they are child. But no one should be afraid of unpredictable problems. All problems are great opportunity of learning. Courage is essential input to overcome the crisis. I am always available at jcgogoi@gmail.com. Thank you all.